Hey everybody, I'm live. It worked. Welcome to Open Space for Monday, January 27th, 2020. So before we get into all of the chat and all of that today, apparently Nightbot isn't working again, so I'll try and fix that. So before we get into what's going on today, just to let you know some upcoming stuff, we've got a new episode coming tomorrow, which it's going to go to the patrons a little later than we were hoping. So it should be going out tonight to the patrons. It's all about shadow ecosystem, which is a really cool idea, and I've been thinking about this quite a lot. And we're doing a bit of a different experiment today, which is that we're going to, with this next episode. Sorry, I'm like working on 5 different things all at the same time. So the plan is that we're going to, at the beginning of the episode, I've got a little ramble. So it's just about a minute, because in doing more episodes, and you can see now all the Guide to Space episodes are just my voice, and then we've got a whole bunch of really cool graphics over top of it, and that's great. It allows me to like quickly write an episode, record the audio, give it to Chad. Chad puts it together, and then we were able to put the episode out the door. But it's kind of lost the connection to me, right? And so like the people who showed up, the 400,000 people who showed up on the Betelgeuse episode, don't have any real connection to the channel and the other stuff that we do here and all of that. And so I wanted to kind of bring that. And it used to be I would just be in front of the camera and do the spiel, and then we would do the video. And so with this more streamlined version, it's kind of lost a little bit of its humanity. So for the next 3 episodes, I've recorded just a 1 minute like director's note, writer's note, Fraser's note at the beginning of the episode about how sort of what led to me picking this episode and what I think is kind of really cool about the idea. And then we go into the actual episode, and we'll see, that's very quick for me to do while I'm doing the QA portion. So the next 3 episodes are going to have this running as an experiment. So let me know what you think. Like I said, it's sort of it just kind of feels like it's just another generic narrator going on, and that's not the sense that I want to give people in watching the episodes. I showed you last week the new pictures from the telescope. Did a star party with Skylius Wednesday, I forget now. Wednesday, I think. And we took a bunch of more great pictures. So we're really cranking with the new telescope. I am pretty excited about it. So first step is make the telescope go, practice out some of these star party things, and then I'm going to try to invite guests, probably do them Sunday nights when we have dark skies, because that's when we used to do the star parties, and try to bring back some of the old friends and try to build it up. But again, with this bedrock of really cool telescopes that are always available, so we'll always have amazing pictures to share. So we were going to have a guest. It was going to be Phil Metger, who comes from the University of Florida, and one of my favorite people to follow online. He works on all kinds of projects, working on lunar simulant to help figure out how rovers are going to work on the moon. He was one of the people who helped develop the steam-powered rocket, like space engine. So he was going to be coming today, but then some stuff sort of made his schedule busy. So he's going to be back near the end of February. But we've got a bunch of episodes with guests lined up, but then freeform, just me also. So let me know what you think, what you want. As always, this is all about you. All right, so let's get cranking and let's get into this week's question show. And again, I have no idea what this is going to be about. This is all up to you. If the topics are boring, it's not my fault. So Tim Smith asks, any news on the Starlink launch tomorrow? No news. It was supposed to launch Sunday, and then the weather was bad, and so they pushed it to today, and now the weather is bad, and so they've pushed it to tomorrow. So it should launch on Tuesday. And the thing with this is SpaceX isn't taking any chances. They, the because it's their rocket and their satellites, they're going to wait for, and there's no rush to get these satellites into space. They're just going to wait for the ideal conditions. But the thing that's funny is like how weird this is to see these satellites going every 2 weeks. Like, I know we were told that there were going to be satellite launches every 2 weeks, but I don't think we really appreciated it in some kind of, I don't know, some kind of emotional level. But you're like, satellites launched, and then you're sort of dealing with like, here's the cool pictures and all the videos, and here's where they went, and then satellites launched, like, oh, there's more, and so we're just like completely overwhelmed by this. And it's funny, like, there's a whole industry of people who follow, and like Tim Dodd, Everyday Astronaut, and there's a whole bunch of people that follow all of the stuff that's happening with SpaceX, and they're covering every launch. But I wonder if we're going to get to this point where it's just too much. It's just like how do you, it's like, it would be like covering every commercial airliner that takes off and delivers supplies or people to some location. Like, it's just going to be crazy. So I was talking about upcoming episodes. I totally forgot. So the shadow ecosystem is the one that's going to be happening tomorrow. And people asked me to do premieres. So I did a couple of premieres last week, but I did them last minute. I gave you like an hour of notice. And people really enjoyed it because I was in there in the chat, and I was chatting with everybody and answering more questions about the episode. And I really like the process because it catches any mistakes that I might make. And then we can fix the mistake, pull the episode down, re-render it, put another one up, and not have to, even if anything was even slightly confusing. So I think it's a great process. So we will give you more notice. So tomorrow it's going to be the episode on the shadow biosphere. Friday's episode is going to be about the supernova 2006 GY that looks like it was a white dwarf spiraling into a red giant, which is just awesome. And then next Tuesday's episode is about the abort systems, such as the pad abort system, in-flight abort system, and even some weird ideas for how to retrieve an astronaut if their spaceship is broken and they need to return through to land, through the atmosphere. So anyway, I'm gonna try and give more notice so that you've got like 24 hours of notice on these premieres, so if you want to show up for them. At the same time, though, last time I tried to do a premiere and gave a 24-hour notice, a lot of people complained. Like, they just hated this idea of a premiere. They want to watch the video right now. They don't want to know that a video is going to happen in the future. And I was originally kind of, I don't know, I understood that, and I sort of backed away from the idea. But then with the premieres that we had last week, everybody had so much fun. So I think that if you want to show up and hang out with us while we watch the show, you can. And if you don't want to, also cool. Just wait 20 extra minutes and then you can watch it. So, all right. So let's get on to more questions. Dragon King, if we did encounter aliens, do you think they would be friendly? It's a tough question. There's sort of two camps to this, right? So the one camp is that any civilization that is capable of harnessing the kinds of power required to cross the gulfs from world to world should be very advanced and probably fairly emotionally stable, very not really warlike, because it's like, how do you get that advanced and still be having war all the time? So the hope is, and there's not a lot of really good reasons to go to other star systems. You don't need the resources, right? It's pretty much limitless in your own star system. You don't need to steal the water, right? Like you would go to another star system to greet the inhabitants. Ideally, you would want to make friends with them, right? That you would want them to make friends with us. But there's another really good reason why you would want to go to other star systems and greet the inhabitants, and that would be, of course, to wipe them out. Because any inhabitant today, any pre-industrial civilization, any new scientific civilization is a future competitor for the resources of the galaxy. And so some advanced civilization might say, okay, we want the entire Milky Way to ourselves. We don't want any competitors. So we are going to build a fleet of self-replicating robot probes. They're going to go from star system to star system. If they find a civilization at any stage, they're going to return it to the Stone Age. And that way, when we show up, in the future, when we finally get around to wanting to use those resources, there won't be any competitors. And that is another. And this is the idea of the Berserkers. I think it was, Fred Saberhagen's books, The Berserkers. So there could be satellites here in the solar system waiting for us to demonstrate that we're an intelligent civilization. And then they'll get the signal and they will return us to a non-competitive state. So we don't know, right? Obviously, we don't have enough information. There's just us. And from what we can tell, all we have seen so far, that we're the only intelligent civilization that we have ever seen in the entire Milky Way, in the entire universe. So until we find some others, we won't know whether we are, whether they're nice or whether they're mean. But the reality is that any civilization that can cross the gulfs between stars, we are not a threat to them. So they can do whatever they want. I hope they're nice. Will to Duck 007, why do some planets spin in the opposite direction? So there's all of the planets in general spin in the same direction. The direction that the Earth turns when you look at it, that is the same direction that the Sun is turning, that Jupiter is turning, that Mars is turning, etc. Now there's two notable examples. There is Venus, which is turning exactly backwards, and then there is Uranus, which is on its side and turning. And so how did this happen? And there's a couple of ideas, and right now astronomers don't know for certain what actually caused it, right? The one possibility is that it was just that the planets migrated. And so we know that, for example, in the early solar system, you had Jupiter. It was probably Jupiter, Saturn, Neptune, and then Uranus. So if they're sort of like the sizes as they go down, and that's what you would expect. And then the planets migrated around. Jupiter and Saturn kind of moved inward. Uranus and Neptune shifted outward. Neptune and Uranus shifted places. And in that process, it's possible that as Neptune and Uranus pass each other, Uranus rolled over. A similar situation might have happened in the inner solar system with Venus. It might have rolled over. But then there's some other ideas, which are, of course, things like big impacts, like what happened with to create the Earth's moon. Maybe a planetoid crashed into Venus and rolled it over. The other possibility is that maybe it was the lack of a large moon and just rolled it over, or maybe it engulfed its moon, right? It created a moon, but the moon wasn't up far enough to be able to fully orbit around for billions of years, and it just came colliding back into the planet, and that caused it to roll over. So we don't really know. We will find out as more research is done. I mean, this is one of the big reasons why we really need to go back to both of them. We need to go back to Venus, and we need to go back to Uranus and Neptune, and to study them better. And right now, there's no hard plans to go back to the outer gas giant, the outer ice giants, which sucks. Be awesome. VeggieT 2009, what do you think of the XKCD reimagining of the solar system? I thought it was funny. And in fact, so speaking of people who had a hot take on that, so Phil Metger, the person who I said was going to be my guest, he had a really in-depth breakdown of everything that would happen in this reimagining from XKCD, all of the things that would go wrong in the solar system, even things that we kind of do enjoy. So even though some of them would be pretty cool, some of them would be pretty bad. So definitely, I apologize. I hope somebody can put a link into the show notes. It's a big long multi-tweet thread that Phil Metger put on there. Let's see. Zachary Handy, what do you think of the AIN from Subnautica Below Zero? I haven't played Subnautica Below Zero. I played Subnautica and I really enjoyed it, but I haven't played the sequel. I knew I should. So I'm sorry. Orlando St. Sebastian, what would be the effect of two orbiting pulsars and each intermittently hitting each other with its energy beam? I have no idea. I mean, that sounds like a question for an astrophysicist and not me. So, I can't think of a piece of research where that happened, but it's just light. Like, it's just, they're hitting each other with their radio waves. So I can't imagine it would cause that much of an impact. We know that pulsars do spiral into each other because of, they're losing energy because they're emanating gravitational waves. And those aren't very strong. So I can't imagine they would actually change their orbital characteristics from the pulsars zapping each other with their radio beams every few milliseconds. It'd be super weird. I mean, I guess however long it takes them to orbit around each other and hit each other with their beams. Oh, it's a good question. That's the kind of thing that I will have to bring in an expert to be able to help answer that question. But just sort of from my rudimentary thinking of the process, it doesn't seem like it would be that big of a scale. Let's see. Zapfan, is there anything in Betelgeuse's core that could trigger a gravitational wave without it blowing up, like switch from the fusion of neon to silicon or something? Not that I'm aware of. This is, of course, the story that the LIGO-Virgo Observatory detected a gravitational wave in the region of Betelgeuse about a week ago. And I had a bunch of people email me and say, is this real? Did this really happen? And I know Anton did a wildly successful video. I clearly picked the wrong topic that week because Anton from What to Math he just crushed it with the video that he did on it. I haven't watched it, but I saw the number of people who watched it. And yeah, so this happened. There definitely were gravitational waves that came from the region of Betelgeuse, but it's most likely a coincidence. The resolution of LIGO and Virgo isn't good enough to know exactly where the gravitational wave came from, but it did come from a region that is, say within 10 times the distance of the moon nearby Betelgeuse. So it's actually a fairly small chunk of the sky, but coincidences happen. If Betelgeuse did explode, I mean, there are gravitational waves that would be released by a supernova, by a core collapse supernova. And the current generation of gravitational wave observatories can't find them, but future gravitational wave observatories will be able to find them. They'll be able to find all kinds of crazy stuff. So, that the video that I did last week talking about the future of gravitational wave observatories, I mentioned in that one of them would be able to detect core collapse supernova. And they would have the precision to know exactly where it's coming from. Like the future ones will know which star just generated a core collapse supernova. And they will get that before the light comes, right? Which is incredible. They'll get it. It'll go gravitational waves, then neutrinos, and then the light. And it's because the gravitational waves are released sort of instantly. The neutrinos happen when the core comes together and the black hole forms, and the neutrinos, 99% of a supernova is released in neutrinos, and they can escape the material around the core of the star, while the light, the radiation, is blocked by all the solar material, just all this material falling in and heating up. And so the neutrinos don't move quite the speed of light. They're just a fraction shorter than the speed of light. But for the vast distances, it's effectively the speed of light. And so we would get the gravitational waves, then we get the neutrinos, and then the light, like 4 hours later, would show up one after the other. And so to be able to get that gravitational wave alert, astronomers can know where to turn their telescopes and then watch as the supernova happens. They could even, I guess in theory, see what the star was as it was starting to come together. Anyway, I can't wait until this next round, but we need things like LISA or the Cosmic Explorer, so stay tuned. Doug Ellis asks, does your deaf dog bark? And could the ISS leave orbit for a more exciting mission? My deaf dog does bark quite a bit, actually. We should make her bark. Can you make her bark? I don't think we can. We can get her pretty zazzed up, but I mean, it doesn't sound quite like a normal bark. It sounds a little different. At some point, I'll try and get her to do this on command in a future episode. No, ISS can't leave the orbit of the Earth for a more interesting mission. It is not designed to go anywhere else. It is, it's built to be under the protection of the Earth's magnetosphere. So it just doesn't have any kind of radiation protection to be able to handle going anywhere else. So when it finishes its mission, it's going to reorbit the atmosphere and crash into the atmosphere and be deorbited into the Pacific Ocean, into the spacecraft graveyard. Pedal listen. How small could a black hole be? In theory. So the smallest black hole that you can get naturally is going to be the stellar mass black holes. And those are the ones that are formed when a star with like 10 plus times the mass of the sun explodes as a supernova. Maybe 20? Bigger, more massive than the sun. A lot. And so if they're less massive, but you get a supernova, you get a neutron star as the remnant. And if they're more massive, then you get a black hole. And then they end up with several times the mass of the sun as the black hole. And that's like the smallest possible way you can get a black hole just naturally in the universe. And the exact size of that is still being figured out as more and more observations are being made. And of course, back to gravitational waves. When the gravitational wave observatories come in, we will know precisely how small the smallest black holes are, or how massive the least massive black holes are. But in theory, you could have black holes that were formed at the very beginning of the universe when the entire universe was in this incredibly compressed state. In theory, if there were over and under densities in any part of the Big Bang, then you would have essentially black holes form just instantaneously in the earliest moments of the universe. And these are known as primordial black holes. And they could come in any mass. So there could be primordial black holes that are the mass of the Earth, or primordial black holes that are the mass of the sun, or the mass of a chair. And then they would just be out there in the universe today. And this has been thought one of the reasons why there could be one of the explanations for dark matter, although not very many people hold to that. But what's cool about this idea is that these black holes, if Stephen Hawking is right, they would be evaporating like the larger black holes are expected to. And the smaller, the less massive a black hole is, the faster it's going to evaporate. And so in theory, you're going to get these tiny black holes, and a certain number of them will have already evaporated in the age of the universe. And so if astronomers look out, they should see a minimum mass of black hole, which is the smallest size to not have evaporated so far. And that would just be the greatest, right? It would mean that, yes, black holes were formed during the Big Bang. These primordial black holes are out there. And Hawking is right that all of the least massive ones have already evaporated. And what's left are the bigger ones. It's a great idea. So stay tuned. Let's wait for those really amazing gravitational wave observatories, because those will probably be the machines that will be required to find them. Dr. Ed Alcott, are they going to deorbit the failing DirecTV satellite? So we did a story on that. I think it's a geosynchronous orbit, right? So you can't deorbit it. All they can do is move it to an orbit that's farther away from the rest of the satellite, so that if it does explode and cause debris, it's not going to cause any damage. I mean, they're like 35,000 kilometers away from the Earth, so they don't deorbit. They just, I mean, the geosynchronous satellites are effectively going to be in space forever. That's our space junk legacy to the universe. William Beckham, have you seen The Edge of the Universe on Netflix? Interesting topic on radio astronomy in episode 2. I have not. I tend not to watch documentaries and YouTube videos on space and astronomy. I mean, I used to love them as a child. I watched Cosmos and all kinds of stuff. But now, because it's my job, I don't want to be influenced by just how people are, what kinds of topics people are thinking about, what kinds of, like, just how they're structuring their arguments, anything. I don't want to know. And so I do feel bad because I'll see some really cool episode. Like I mentioned, we did this episode on abort systems coming up in next Tuesday. And I saw that Tim Dodd from Everyday Astronaut had done an episode on whether or not Starship should have an abort system. And so I didn't know that he had done an episode on abort systems, and then I wrote the episode. And I'm like, okay, well, I'm just going to link to Tim's video. I haven't watched it. I assume it's good, right? Everything he does is great, but I can't watch it because I don't want to steal his ideas. I don't want to know. And so it's even gotten to the point now where I can't watch really anything space related that isn't just the direct source. Like I read journals, I read press releases, I talk to people, but I don't watch or I don't listen to any podcasts that are related to space. It's just like at a certain point, I have to maintain a certain amount of just like a bubble that I just stick to the sources and not try to watch anything else because it does get into your head, and I don't want to do that. So, Rike Haida, wait, did I get this right? Does a black hole evaporate? Yeah, that's the theory. This is what Hawking radiation is this idea that black holes evaporate over time. And I mean, we've talked about this many times, but just do a search for black hole evaporation on YouTube and you'll see some great episodes. I highly recommend the one from PBS Spacetime, which I did watch, mostly because he helps clear up a misconception about the way this works. So I did watch that. So definitely watch the PBS Spacetime episode on black hole evaporation. Hopefully someone will put a link into the comments. Over on Twitch, Spaghetti Bowl says, how does something evaporate when all the matter can't escape? Radiation. Yeah, so same situation, right? Take a look, black hole evaporation. You'll find some great videos that explain what's going on. Rafael Esperadio. Does everything produce gravitational waves, but they're just too weak to be detected? Earth blocks interferes on them, so we can't detect them. Do we produce a gravitational wave with a clap? Yes, you do. I'm making gravitational waves right now, and so everything, any mass moving in the universe creates gravitational waves. But the key is that you need the most massive, most dense objects in the universe to be able to even detect them at any kind of distance. But in theory, you are. Sebas 1509. How about Kurzgesagt? Yeah, Kurzgesagt. Anyway, I gotta practice saying that. Yeah, they did a video on black holes. It's possible that I wrote it, so that's where my logo comes from. So check that out. Theirs is good, but it falls into the same kind of misconception that I wrote that the PBS Spacetime one clears up. So I recommend the PBS Spacetime one over the Kurzgesagt one, even though I wrote it. Samuel Baker. Hey, Fraser, do you know if the James Webb Space Telescope will have the ability to confirm the existence of quark stars? So for people who don't know, quark stars are a theoretical intermediate stage between a neutron star and a black hole. So, like, I'll give you an example, right? You have a like a white dwarf, and a white dwarf can be pulling in material from some partner star. And when it gets to this magic 1.4 times the mass of the sun, the entire star undergoes a thermonuclear explosion. It essentially becomes the right mass and pressure and temperature to fuse carbon. And the whole thing's made of carbon, so the whole thing just explodes. And so imagine this idea. You've got a neutron star, which is already sort of one level more compact than a white dwarf, but it's accreting material from some stellar neighbor. And could it get to some point where it's got enough material that it goes crunch one more time, but not enough, maybe a point where there's some intermediate level, and this has been theorized. Could James Webb isn't necessarily the best machine to be able to see this kind of thing, because think about like what kind of, it's going to be giving off potentially radiation similar to a neutron star, but it's going to be a little different, and you will need to figure that out. The interesting idea to sort of detect these things is it's not about infrared radiation, but it's about that phase shift, right? Where you've got the neutron star crunching down to the quark star, maybe the quark star crunching down to a black hole. And so in theory, there should be some kind of burst of radiation when this happens. And that's been one idea for a fast radio burst, that because they happen once many times, they're randomly located around the whole universe. They're obviously in galaxies that are super far away. That could be a signal that's coming from quark stars forming. But James Webb won't necessarily be the right tool to find it. You want either high energy stuff or just different ways of detecting it. Nancy wants to know if I've watched Picard. Thoughts? Yeah, I watched the first episode of Picard, and I thought it was fine. It was fine. It was too early to tell, right? It was, I mean, on the one hand, Patrick Stewart's in it, and so I mentioned this in Astronomy Cast. It's like, he's like the baby Yoda of The Mandalorian. Like, how can you not be overwhelmed by emotion watching Patrick Stewart be Jean-Luc Picard again? It's amazing. The actual story itself, I don't know, too early to tell. I'll keep watching it for sure. I wasn't, hating it, so. Arjone, do you think that other civilizations may be held back because they never created an economic system that boosts their technological development before they go extinct? Well, so I mean, if other civilizations, if there are intelligent civilizations out there, we don't know. Another idea of sort of for why they may have never formed the ability to be an advanced civilization is, could be like they're a marine environment, and they're in a marine environment, and so they could never develop fire or wheels or things like that. It was only, tool use, and so they could be incredibly intelligent, but they can't actually affect their environment beyond whatever they can do under the water. So you can imagine all kinds of scenarios which would prevent any one civilization from being able to develop further. But the universe is a big place. There are hundreds of billions of stars in the Milky Way. And so whatever happens, even if it's incredibly remote, will happen a bunch of times. And as we talked about in several episodes, right? Wherever that civilization starts, they will settle the entire Milky Way within a couple of million years. So it doesn't matter where they start. And for every civilization that doesn't want to settle the entire Milky Way, there will be others that will. And they will be potentially, we talked about early at the beginning of this episode, they will be looking to study and potentially snuff out their competition. So there could be all kinds of reasons why a civilization may fail to advance. I mean, why are we the ones with cars and houses and not I don't know, why did our ancestors get us to the state and not the octopuses? And who knows? Suthin Scientist, can you do a video on terraforming Ganymede? hasn't Isaac Arthur done that? He's covered, like, he's terraformed everything. Um, I can't imagine what value we would get from terraforming Ganymede. It's like really cold. It's really far away. You got a lot of water, but apart from that, I mean, it's a terrible place. I don't know. I mean, I want to study it scientifically, but I sure don't want to live there. I mean, Titan out by Saturn, it's got going for it's got an atmosphere, right? Ganymede doesn't have an atmosphere. So, I don't know. It just doesn't sound great. So I can't imagine any reason to um, for us to want to terraform and try to live on places like that. I think we're going to build space stations, and it could very well be. I mean, I love in the Expanse they've got a space station or like a station on Ganymede because it's like this gateway to the outer solar system, a place where people can go and collect resources and then move into and out of the solar system. But I can't imagine trying to turn that into a livable place. That said, when the sun does die and turn into a red giant, there will be this time when Ganymede is like at the perfect distance and the whole place melts and it becomes a warm water world orbiting around Jupiter, which is kind of a crazy idea. So stay tuned, and the solar system will terraform it for you. Um, oh, someone's asking me to mention the topic of Phil Metzger's tweet again. Yeah, so Phil Metzger was talking about this reimagined solar system from XKCD, and he was explaining, going through in detail the solar system impact of each of the suggestions from Randall Munroe. So that's the episode. No, that's the tweet storm. It was like 15 tweets all linked together, each one sort of handling a different issue. Sean Martin is noting R.I.P. Gus Grissom, Ed White, Roger Chaffee, 1/27/67. Yeah, we have entered the sad time of space exploration. We have the Apollo 1 disaster happened on this day in 1967. We have the upcoming the Challenger and Columbia accidents all happened in roughly the same time. So you sort of have this 1, 2, 3 punch every year. And I got this working on this upcoming episode about abort systems. I was writing about abort systems for the space shuttle and for the Crew Dragon and that. And so you have to go through the fact that the shuttle astronauts died because they didn't have a in-air abort system, right? Or a flight abort system. Once the shuttle lifts off the pad, and if there's anything wrong with the orbiter itself, there was no way to save the astronauts. And the truth, like, people sort of see the explosion of the Challenger, and they see the big, the twin solid rocket boosters take off, and they see the explosion of the main tank, and they think, well, that's awful, and they died. But the reality is that the orbiter was, the main tank sort of collapsed on itself and tore away from the orbiter, and the orbiter kept going. And then the wings and the tail came off the orbiter, and then it broke up more. It broke up and crashed into the ocean. It's really hard to think about. And as we sort of move into this next phase of space exploration, and you think about what the risks that people are going to be taking, it's like, don't forget how many people died and how dangerous this is. And I'm really glad. I mean, I loved the space shuttle. I loved how it looked, how it worked. But I am really grateful that we're kind of going back to this simpler, safer, more resilient launch system, like what's happening with Crew Dragon, right? If it's on the pad and there's a problem, the thing pops away and everybody's safe. If it gets into the air and there's a problem, the thing pops away and everybody's safe. So you really have abort options every way up to docking with the International Space Station. And then the Crew Dragon is the abort system for the International Space Station. So I think this is the right way to move forward with just getting humans into space. And if and when Starship flies, it won't have an abort system. And so is that a step back? Are we going to see some terrible accidents? I mean, almost certainly, right? I mean, we see airliner accidents. So anyway, as you go through these next couple of weeks, it all brings it back to the surface. And I wasn't there for the Apollo 1 fire, but I was there for Challenger. As a kid, I was always say I was delivering papers, and all the newspapers had, the newspaper had the Challenger explosion on it. And that's how I found out about it. Was I went to school, came home, did my paper route, and it was just like Challenger, Challenger, Challenger. But with the loss of Columbia, I was reporting it. I woke up and this was the news, and I had to spend my whole day sort of following it step by step and reporting it, and for weeks after that. And it's terrible. So anyway, I hope all of you going through this kind of remember and have sort of warm thoughts in your mind for all the lives that were lost in exploring space. It's still incredibly dangerous, not to be taken lightly. The forces, the energies involved. This is still a very dangerous thing that people are approaching, and we need to take it very seriously. Liquid Flame says, didn't they have ejection seats in early designs of the shuttle, or was them built with them, or they took them out? I don't know if they ever had ejection seats. So as part of this, you know what? I'm just going to wait. You're going to have to watch the episode that we did on abort systems, which comes out a week today. So stay tuned. We cover some really interesting ideas, including like little mini capsules inside rockets that would pop out and keep an individual astronaut safe. Rhino Throton, where's the best place to go on an amateur astronomy photography vacation in North America? That's a great question. I love this. All right. So there's like 3 things that you want to see, and they're all in different places. So you could probably get 2 of them together, but definitely not one of them. So the 3 things that you'll want to see as an astronomy vacation is you're going to want to see the night sky. You want to see dark skies. And for that, you're going to want to be somewhere in the Midwest, anywhere from, like if you draw a line, like right through the middle of the United States to the west, probably down in, Arizona, New Mexico, that area, the sky, you can get out into the desert and get access to really nice dark skies. And then wherever you look, the sky is just going to be phenomenal. The second thing you're going to want to be able to do is actually see the northern lights. And that's, you're going to have to go to northern Alaska or northern Canada to be able to see that. But when you see the northern lights, they're just absolutely stunning. It's amazing. There's nothing like it. Iceland is good too, though. Iceland is the temperature's a lot more reasonable for how far north you are. So if you want to see the northern lights, I do recommend Iceland. The third thing is you want to watch a rocket launch. And that's easy to do. Like I go on about this, just how easy it is for people to just go to Florida, and now when rockets are launching like every 2 weeks, so you should be able to see a rocket launch almost any time. So get a hotel in Cocoa Beach, which is sort of the nice beach that faces Cape Canaveral. Get a hotel room that faces the water, and at the time of the launch, sit on your hotel patio or down at the bar and watch a rocket launch. And you'll see almost as good a view as we get to see when we're the media out at Cape Canaveral, because they still keep us pretty far away from the rocket. But it is totally worth doing. You feel the power of the rocket taking off, the flames, the sounds, and just this idea that this is our connection to the entire universe. And you're watching us. It's like it's like a lifeline. It's like a ladder that we are climbing, rocket launch by rocket launch, and you get to be a part of it. And there's never a time that it's not exciting. So do that. Those 3 things. Ben Kalo is saying really great photography on Universe Today's Instagram recently. Yeah, we just crossed the 200,000 mark on Instagram, and for followers, and I think we've got to have featured maybe 1,500 astrophotographers on our Instagram channel. I essentially give the keys to our channel to a different astrophotographer every day, and they're doing great. And then I feature one of those pictures in my newsletter every week. So universetoday.com/newsletter. But if you're an astrophotographer and you want me to share your work, just use the hashtag UniverseToday, and then at some point I will send you a message saying, hey, thanks for using the hashtag. Do you want to take over? Let me know, and I send the instructions, and then they do the takeover. Everyone asks, Sergio Best, sci-fi books recommendations. Tell me, like, I've mentioned a bunch of the books that I really love, but I would love to hear your all's recommendations in the chat. So why don't you, the people who are watching right now, go ahead and throw all of your book series recommendations there for Sergio. You know, I've so many books that I like. Newer books, older books, but I would love to hear, and I've mentioned it a bunch of times, so I'd love to see what people recommend. So let me know. What is the Instagram account? It's Universe Today on Instagram. So, let me see. Can I share it? I'll just show you my phone. That's how this works. And then for the people listening to the podcast, you know. So, you can see these. So pretty much each line is a different photographer, right? So every day, just a different astrophotographer sharing their work. And so it's deep sky stuff, it's Milky Way stuff, it's aurora stuff, it's space flight stuff. And, you know, I kind of, you know, I'm the editor, I'm the moderator of it. And so it's great because I get a chance to just see all this different work. And sometimes I share just artists. I love it. Chris Colvin, Event Horizon, just sent me here. Hey, Event Horizon, Jean-Michel Gaudier and friends. Are there any major events that you're hoping for or looking forward to for the Northern Hemisphere in 2020? Fingers crossed for another Oumuamua or Borisov. Yeah, so in 2020, the big event that I'm most looking forward to is there's going to be a conjunction between Saturn and Jupiter happening near the end of the year. I forget the exact date. In November? And so they're going to be so close in the sky that you will be able to see them in the same field of view in a telescope, which is just mind-bending. So you'll point your telescope at what looks like Jupiter, and there will be Saturn and Jupiter in the same field of view. And the moons, it'll be incredible. So that is going to be just epic. Hands down, best event of the year by like a factor of 10. So stay tuned. Astro B asks, where do I give notice of my OPT telescope sessions? I don't give any notice. And there's a couple of reasons. So partly it's because even with this incredible observatory at my disposal, the skies can be really problematic. And so last night I was going to fire up the telescope, but then the wind speeds were too high, so I couldn't. And so once I've done, like, I'm still figuring out how to just make it go technically. Like, how do I get the images coming from the telescope and then share those out onto the internet? And so if you watch the thing that I did with Skylius, we're kind of there, I think. But how do I bring in some more guests? Then how do I bring in other telescopes? And how do I bring in additional sort of material to help us understand what it is that we're looking at, et cetera, et cetera. And so, you know, I have in my mind how I want this to look, but I also know that the only way to do this is just thrash around in public, trying to make this go until I feel like it's smoother. And then after I've done, I don't know, 50 of them, then I'll feel like it's figured out. So I think that is... So for now, if you follow Twitch, if you follow me on Twitch, .tv/fcain, then you should get a notification when I have gone live. You should show up by email or notification on your phone or whatever. I'm then, when I feel like I'm not completely embarrassing myself, then I'll be doing them here on my YouTube channel. I'll probably pick a, like we used to do the star parties every Sunday night, so I'll probably do them again on Sunday nights. And then, and probably around new moon, so we'll probably do them, twice a month around then. But then Twitch, I'll be doing them all the time, right? Just whenever I have some new experiment that I want to test out. So for now, you've just got to let YouTube and Twitch let you know when this is actually happening. Danny the GFP on Twitch. If you could spend an hour looking into the night sky from Earth at any time in Earth's history, what year would you pick and why? So I don't know the year, but I know the kinds of events that I would want to see, right? I would want to see a supernova. Like, there have been stars as bright as Betelgeuse explode closer than Betelgeuse. Wouldn't it be cool to see one go off 50 light years away, 60 light years away, where it's safe, right? So that would be cool. I would like to see a bright comet. So we did an episode about panspermia, about galactic panspermia, that comets could be carrying material out from Earth's atmosphere out to other solar systems. So imagine a comet that gets so close to the Earth that it scrapes through the atmosphere and then heads back out to space. Can you imagine that? Right? Watching that happen from the ground, that would just be madness. It'd be amazing. So that would be incredible. So talk about seeing a bright, naked-eye comet. Eclipses would be great. So there are events, like really incredible events, that I would love to be able to see, as long as they're safe. So I don't know when they happened, but they do happen. Astro B asks, will you do a Messier marathon? Yeah, I would love to do a Messier marathon. That's definitely been in the list, is I want to do a Messier marathon at some point where we will try to hit all the Messier objects over the course of a night and give you some perspective on each one of them as we go. Neil Yu, what kind of propulsion could the Tic Tac drone UFO have used? No hot thrust, and can Fraser interview the Navy wing commander pilot soon, please? I probably won't interview the Navy pilot. Obviously, if someone wants to set up the interview, I can definitely talk to him. Who knows, right? Like, we don't know. It's called an unidentified flying object. I could ramble off probably 20 alternative explanations for it was an alien spaceship for what people saw. And experts in this field could probably rattle off 100 different explanations that could possibly explain, including aliens, time travelers, magic, angels, right? Flying unicorns, but also things like problems with the sensors, problem with the radar, problems, just mistakes, infrared, like an infrared reflection seen on a screen, all kinds of things, right? So, or advanced aircraft developed by another state, like Chinese or the Russians, who knows? Or another branch of the U.S. military testing out a vehicle that the Air Force was unfamiliar with and is so classified that no one will even tell them what it was. Who knows? And unfortunately, until you can actually go and interrogate the evidence, until you can go and follow that thing up and take a look at it up close, it just has to remain in the unidentified. So we don't even have enough information. Yeah, glitch in the matrix, Nifty says. Yeah, exactly, right? A break in the simulation. Who knows? But until we can gain more evidence, it just has to be unidentified. And don't drive yourself crazy trying to think about what it was. It's just unidentified. It's right there in the U of the F and the O. James T. How can we confirm the Oort cloud exists? So the Oort cloud is this theoretical cloud that surrounds the entire solar system and contains these small icy objects, kind of like the Kuiper belt, but farther out. As far as like 2 light years away, you've got this cloud of ice that surrounds the solar system. How do we know it's there? Well, we can't observe it directly, but we see comets. And so every now and then a long period comet comes into the inner solar system, makes a zip around the sun and flies back out. And sometimes they crash into the sun. And they're pristine. They've never been into the inner solar system ever before. And based on the trajectory that the thing is following, if you look at the trajectory that the comet is coming on, and that allows you to calculate where it started, what is its what is its closest point to the sun and what's its farthest point to the sun. It's aphelion and it's perihelion. And that allows you to figure out that it had to come, one came from over here, and then one came from over there, and then one came from over there. And so they all had to have come from some region that is really far away. And so that's how astronomers think that the Oort cloud is there. From Nancy, is there a proposed scope that would be able to directly image or confirm the Oort cloud? The problem is that even if you're out in the Oort cloud, the objects are still incredibly far apart, and there's not a lot of light out there. So it would be very difficult to actually observe an object that's out in the Oort cloud. But there have been some missions proposed. One example, we did an episode on these ideas of an electric drive, electric sail. And one of the things that it could do is take you out into the Oort cloud fairly rapidly to be able to try and observe them. But it would be really tough. Like, you would want to send a Hubble Space Telescope out to the Oort cloud to find Oort cloud objects, and then use those as potential future flybys. Like, it would be really tricky to be able to do that. Eric 1 asks, do we suspect that other systems have Oort clouds as well? Yeah, I mean, the assumption is that the solar system is pretty normal. We have seen cometary clouds around other solar systems, more like Kuiper belts. And so the theory that, if we see these icy objects in other star systems, the expectation is that they're going to have Oort clouds as well, that the mechanisms that led to creating the various features in the solar system are present in some number of star systems out there across the Milky Way. All right, Janos Anja Relips. Wouldn't water used as a radiation shield become radioactive and therefore toxic to astronauts? So this is a question that's been asked quite a bit. Like, we've talked about how astronauts can use water to protect themselves from radiation. And so the question is, won't the water become radioactive? And the answer is no. Imagine water. The water is it's like stopping bullets. And so you've got these particles that are the cosmic rays are passing so quickly, and they will smash up your DNA if they hit you. But when they hit the water, they hit the water and then they slow down, and then they're just one little atom across all of the water. And so it's not like they are ionizing radiation. They are just very damaging particles. The water stops them. It's just like water wouldn't be poisonous, wouldn't give you a gunshot wound after bullets were shot into it. So no, you can still drink the water, no problem. I know that analogy kind of falls apart. So, all right, so we've reached the end of our hour. Where does the time go? So thank you everyone for hanging out with me today. I will probably have a guest next week. I'm not exactly sure. But I will let you know what as things go. But if not, then there'll be another just open space. This week, again, tomorrow I'll do a premiere. We will watch the new episode of The Guide to Space, starting tomorrow at noon Pacific. But the patrons will get it early, of course. And then later on this week. So tomorrow is the Shadow Biosphere. And then on Friday, we've got Supernova 2006 GY, and then next Tuesday it's going to be Abort Systems, and then beyond that I have no idea. So thanks everybody for watching. Thanks to the patrons. Thanks to the moderators. Thanks to Nightbot. And thanks to everybody who suggested all of their books. This is awesome. So many good books in there. And there's a bunch that I've read that I really liked. But I hope any of you who were wondering what sci-fi books to read, many of these I highly recommend. So, all right. Well, thanks everybody. This was super fun. And I will see you all next week.